Now, okay. So I'm officially recording. So welcome back, everyone. Today we're going to talk about tables. Tomorrow we are going to use it. We're going to go out kind of just around here. We're going to use the drone. And then and Andy, he's one of my master students. He was kind of using one of our drones. Tomorrow we're going to go out, use the drone, post-process the data, and then we're going to load up survey 1, 2, 3, or field maps or quick capture, so we can go collect information just around here. Because when we go to our field trip, or you go and collect data in the field, you're going to have to go and create something, create something related to that. I think we're going to probably just create a survey, and we're going to go collect points around here, and then you get back and they're going to be sitting on my map, like loaded into the cloud if I don't screw everything up. And then you'll have the opportunity to go and create your own survey. What are you collecting? And most importantly, which leads in today, we talk about attributes. Attributes describe the data. They're aspatial, but they describe the data. So when you collect information about a telephone pole, what's the information? You're working for a utility. What's the information you want to collect about a telephone pole? Telephone pole, does it have a serial number? Does it have a condition, potential height? Probably a picture of it, because when we click location, we're going to obviously have the location there as well. And so, because like we said before, when I went, worked for the military, I went out to all these places, Wendell Ford Regional Training Center in Kentucky, or Camp Santiago. And so I had, firing point number, range number, all these other things, because what are the 3 words your boss never wants to hear? I don't know. It's hey, what range number is this? What fire, what type of weapons are fired here? And you're like, oh no. We never want to hear those 3 words. Never want to hear I don't know, because you're gonna have to go back and figure it out. And so likewise, when we start collecting data on Monday or collecting data tomorrow, you're like, hey, what's this a picture of? I don't know, how did you collect it? And all the seminal information that we want to collect with it. So today we're going to talk about attributes. We're going to go much, much further into the weeds than I think we did in geostats, and definitely in data science, where I kind of assumed that you knew all these things. So I posted announcements and everything. Also, I'll post an announcement today. Make sure your bill reflects the $700, because I filed for this stuff like the 25th. And so someone said, hey, it's still not showing up. And I'm like, I filed it a long time ago. Okay. Well, send me the bill, because there should be, I've got the little thing that says your name, and I did it for someone else. I typed in their name and it says, here's the stuff showing up for it that I filed. And I get a little frustrated with the lack of urgency on campus, because I treat it with urgency, and it doesn't seem like everyone else does. But people have no problems just clicking drop from class, and it gets a little frustrating on my end, just because of all the efforts that we went through to get all these things done. So I've got a lot of different things here. I'll talk a little bit about, tabular data and all this other good stuff. But tabular data, as you can imagine, we call these things standalone tables. Standalone tables because they're not connected to points, lines, and polygons. So some of the work that Solomon was doing with a meteorite atlas, he was just creating essentially a standalone table of the latitude and longitude of meteorite strikes in North Carolina and the Southeast U.S., extracted from National Meteorological Society, which basically links it to like a Google Earth, but doesn't have them all in one place. And what our job is to do is turn those into map form. So we're going to talk about some of the different tricks and techniques in order to do that. I've linked to a bunch of different, tables that I have, but a lot of times if we see something like birth defect rates, and it's in the back corner there, that's starting to get faded right there, ADHD, or ulcerative colitis, a lot of these data are just sitting in a big table that have county rate, state rate, county rate, or whatever we're looking at. And it'd be really cool to look at a map, because someone like me, I would think something like ADHD is stochastic or random in nature, right? Wouldn't you just think it's just random that someone has, there's not a spatial relationship with this. Same thing with like birth defects. Is there a spatial pattern with birth defects? I would think so. It's like basically individual choices combined with genetics and randomness that lead to birth defects. But when you look at the map in the back, southeast portion of the North Carolina has got a lot higher birth defect rates than other parts of the state. And remember we said yesterday, we're not the why people, we're the where people. But you can start to make some assumptions to figure out, well, why are birth defects lower there? And we can look at longitudinal studies with public health or KRA or Kinesiology Recreation Administration, or well as our partners over in nursing, which are now part of our college. So we're going to talk about tables today. This is a good example of tabular data. This is the Guilford County GIS viewer. There's probably over in Guilford County 3 or 4 people. That's all they do for a living. One of our former students who sat right where Solomon sits, his name's Zuri. This is what he does for Durham County. This is all he does is manage the GIS data viewer so you can look up your parcels. And you can see here, this is just a nice, pretty GIS map. And like I said before, at the end of the semester, he got promoted and basically his position is now looking for a new person. And that could be one of us. That could be someone sitting in here starting out at $55,000 a year to do this and working your way up from here. You can see here the municipalities and all that other good stuff, but we can zoom in. I zoom in, we start to see imagery. Why don't you see the imagery when it's all zoomed down? Pixels. Well, what do we have? I like this word pixels, but why? What's so special about the pixels? Size of them. What is it? What about the size of them? They're really, really small. So if we're kind of zoomed out at this scale, it's going to take longer and longer to render these. And on any web page, if you got to sit there and wait for stuff to show up, what do? I click a little X and get off of it and say, I don't want to do this anymore. Okay? And so there are scale dependencies attached to these because it's relatively easy to draw these points, lines, and polygons right here. These vectors, vector objects that we talked about yesterday. It takes a lot longer to draw these individual pixels. And it takes a lot longer to start to draw the individual parcels right here. These are the individual parcels or chunks of land that we can look at here. And so I can go and I don't even know where this, I guess there's a golf course over this way. But I can click on this house right here. We can see, it's got information attached to all these. Oh, we're on Huffine Mill Road in Gibsonville. But this is all the information attached to this particular parcel right there. Now, this is connected to tabular information. All this is connected to tabular information. I can click on the deed in the plat, and that'll give me a history of who bought it and everything, because this data isn't just sitting in one place here, because I bet you there's a person right now that's working on the assessed value, because assessed value helps determine what? Taxes. And I know over in Guilford County, we're going to have a new tax assessment, so all of our bills are going to go up. All of our tax bills are going to go up. Same thing with the property type in the neighborhood. And so these data aren't sitting right there because I don't think anyone in Guilford County wants the person in charge of the assessed value to go play with the legal descriptions or the grades or any of this other information. So there are subtables within these that look at these here. We can go type in names right here. So we can go type in, Emil Mulrooney, something like this lady, Erica. And so we can look at this. It was good a few years ago. We used to type in Mulrooney. My ex-wife still used my last name. So that was not, my wife did not like that, let's say. My ex-wife was not my wife was not a fan of that. But you can click on this one here. These are the pictures I was showing yesterday, but we can click on this. You can see these people have this, assessed value, deed, plat, zoning, and all that other good stuff here. Some other tabular data that we can look at as well is crime data. We can go to something called the OpenGIS website, and it's got lots of basically open data. We know about open data from data science class because that's the big push these days. You know, the whole idea of data equity. You know, if you create data with like federal funds, it should be accessible to everyone because it's created with federal funds. And so we're starting to create these open data hubs. We have something called COPE, we have something called CODE, Center for Data Excellence or Center for Data Equity. And so we've got these open data hubs here where I can look at every crime in Durham in 2025. I can filter these and I see it's at 800 Park Avenue, 700 South Alston Avenue, 0 Dayton Street, 900 Chalk Level Road. If I know, have an address right here, can you turn this into a point on a map? Yeah, we do this all the time with our phones, right? We just type in and address it. Now, what are some of the challenges that you see? I don't know where 0 trillion court is, you know? So the police officer, the arresting officer, or whatever, probably just put Trillium Court or Dayton Street, and it looks like these are at the blocks right here. So you're not gonna have the exact address because in some cases, there might be, you know, aggravated assault or rape or something like that, where we don't want to give out the information of the individual person right here. So we can look up these here. And if we have a big list of these, there's 7,291 of these rows that we can export out of crimes that occurred. And I'm pretty sure this is just Durham City because Durham Police Department is totally separate. What are you saying? Well, you see something interesting here?
Yeah, looking at the districts, I'm sorry.
Oh, okay, so we see the different districts, the different beats. You see things like 300 West Murray / Elgin Street. So it's going to be hard to tell how to address that. So some of the things you can do later is you might have 10% of these that don't get matched. So you have to go and basically what we call hand jam those and put those in place. Now, that's you. Students do that. I don't do that. I used to do that a long time ago. I don't do that anymore. So, but you can go back and, you know, correct those and put those on there as well. So we can export out this table just for 2025. Me personally, what I like to do is export the whole data set and then bring everything in here because you can see we've got UCR codes, Universal Uniform Crime Reporting Standards. You can see the year stamp. It's got the little comma right here, date reported, incident ID, because it's got a year of 2025, but the date reported was just before midnight. You know, 3 of them probably aren't going to matter because 3 aren't going to kind of determine these patterns. But we've got this tabular data. And we'll talk a little bit about geocoding today, but if you want to learn more about it, guess what? Mapping addresses and places, we have something here. And the one thing about geocoding is that it basically takes up what we call credits. And that's just Esri's code for money. And so we have like 5 million credits or something like that. And so we can use up lots of these credits or whatever, but these credits cost a lot of money. But we have an educational license that we can utilize these. So if we're geocoding like 100,000 addresses, we probably just want to get those to like 50, 60, 100, 1,000 of these addresses. So we were doing a project with someone in criminal justice and they mapped like the whole city's worth of addresses. And then I got a warning and it didn't work. You remember, and it didn't work. So we did it like again and again and again. And so we were getting like warnings from Esri, like, hey, you're running out of credits. You're running out of credits. So I went and spoke to him about getting an educational license so we can increase our number of credits. And then we had one of our former students, he now works for Esri, who was doing the same thing. Like, it didn't work. Let me rerun it. Or, you know, for like a couple of weeks, we like literally had no credits to store and analyze things. So just be careful with the number of credits because when we play with this, and if we have an opportunity for the geocoder today, it'll calculate how many credits it quote unquote costs, you know, because if you're working with like nonprofits, they might give you like a free account, but you only get like 10,000 credits. And everyone here, when I set up your account, I think I set it up for like 1,000 credits, so you can't go and do anything wacky. But some people, you know, still do wacky things, or before I did this, they go do some wacky things. And so be careful when we do this, you know, large scale analysis. So today we're going to talk a little bit about some of the applications of tabular data some of the things to be aware about with tabular data. I'll show some examples and then we'll take a quick break. And then we're just going to open up the project. We're going to open up the same project we had yesterday. It's not going to look as pretty because we don't have the nice pretty colors or mapping median household income or anything like that. But we're going to link and join those to some tabular data. And then the exercise tonight is you go find your own, or I've set up a Google Drive that just has some tables out there that you can create a nice pretty map that you can show up here, because probably 2/3 of these data here at some point in time were created from tabular data, like AIDS mortality or age-adjusted suicide rates. There's just not a map of North Carolina sitting out there, but there's nice big tables from the Department for Health Statistics that have county suicide rate, county suicide rate. It's our job to go and turn these into nice pretty maps. So I'll talk about these a little bit. I'm just kind of making sure everyone's aware of some of the, innate issues that we have with tabular data, because this is my skill set right here. Turning, how do we make GIS data? And Dr. McGinn, didn't you work using GPS stuff back in the day, making
We drove around my early days of GIS when I worked for Delaware County. We literally had a GPS unit on the top of the car, and all new construction, we just drove down the middle of the street to actually create the center line. That was before aerial photography was really accurate and all that stuff. So you literally drove in the car, you had a laptop hooked up, and it traced your path. So if you were a little swervy, that road was curvy. So me and two other interns were 6 hours a day, just drove around in a little Guilford County car and did that for all new construction and all that stuff, and created the street center line. And that street center line, those lines were then uploaded to be used for all this other stuff, right? On the plats and all that stuff. So
was that Derek you went with, or is that before?
no, I had two interns, but that's what I was working with, everything, all those guys.
Yeah. So when we talk about the layers and the themes, the zip codes and the counties and the cities are what we call layers, themes, feature classes, feature services. There's a lot of different names for those. Back in the day, I called these coverages. I got started with GIS when we had these things called coverages, but we have individual instances of those using records, but they're described using building names, street addresses, number of floors. So the information that Dr. McGinn used to collect, remember when we did in data science class, how many different attributes do we have for those roads? There's like 90 different attributes for those roads. So someone had to go back and what's the speed limit? What's the name? What's the county? All those other things. The number of lanes. Does it have a turn lane? Does it have a median? All those. Remember, we created some Python code to check to make sure all of the speed limits were populated. Make sure the speed limits weren't negative.
My very first job was, and some of you guys may know this is my age, but they used to be rural route addresses. So all our addresses now have an address, the street, and then they call 911 addresses. My first job with the elections office that I got into this was taking all the rural routes, converting them to real street addresses. And that was just literally sitting at a thing saying rural route 1, site, lot, this is 421 Main Street. And it was just, because somebody had to do it, right? The first time it's covered, we take advantage of it now because it's in our Google Maps and all that stuff, but somebody had to create the base layer of all this stuff. So
yeah, that's neat.
Fun stuff.
Yeah, I grew up on a rural route, and probably sometime in the 90s after I left, they converted it to a actual number, which was was slightly different. It was one like 133A, and they changed it to like 126 or something when I grew up. And that was kind of funny because we have attributes now, things like sex offenders, North Carolina Sex Offender Registry. This is over in my neck of the woods right there. What are the attributes that you want to know about or anyone would want to know about a sex offender? Registration, birthday, they're like just a couple months ago, younger than me here. Any scars, marks, or whatever, but you can go to the North Carolina Sex Offender Registry, type in your address, and it'll have points on a map that these are the attributes used to describe a sex offender. Same thing with a parcel. This was our parcel before it got split right there, but what is the mailing address? What's the mailing city? What's the total assessed value, building value, all these other things right here. And so what are all the information that you're going to collect about these? Because something like assessed value is going to be collected in a separate table because you don't want the assessed value people messing around with the legal description and the deeds and the zips and all those other things there. So there's a manipulation of what we call a relational database. because data comes in a lot of different forms. This is EPA emissions database that I found here as a DBF file. Just something you can open up in Excel here, but it's got a latitude and a longitude. If you have a latitude and a longitude, can you find it on a map? You bet. It's a lot easier to do it than actual address, even though we love addresses. Here's another one right here where it's got something called a FIPS code. FIPS code stands for Federal Information Processing Standard, and it's basically like an 820 number for your counties, and then your sub-county units such as census tracts, block groups, and even blocks. You know, there might be a lot of other Mary Taylors on campus, but there's only going to be one Mary Taylor with that particular 820 number. There may be other, I don't think there's any other Durham counties out there, but I know there's other Washington counties out there. There's like 31 other Washington counties, but there's only one Washington county that's 37191. That FIPS code attached to it. And then we just keep adding numbers to the end of it that make them unique. Here's some data that we're kind of used to where that we have a county high school graduation rate. So now we're making maps for the state of North Carolina because there's only one Burke County, one Brunswick County in North Carolina. But this has got a graduation rate for 2007, graduation rate for 2012. We can calculate the difference between these if we really wanted to. And so we can extract information from this as well so that these can be mapped. And then some of the stuff that we were looking at, I think, maybe in geostats class where we look at like master databases of age 0, 1, 2, 3 census data for how many males and females are in Burlington, Asheville. A lot of times like your raw data looks like this, and you've got to run some what? Summaries. Remember that summary thing that we did? You know, we can add up columns because this thing might have like 100,000 records, kind of like we did with the death records. You got, 100,000 people die in North Carolina every year. How are we going to wade through that? We use the term big data, but 100,000 really isn't all that big when we're looking at things like business transactions or scanning your little card in at Food Line. There's, probably hundreds of millions of those transactions every day. So we have the difference here between what we call our attribute tables and our standalone tables, because there's a one-to-one relationship with our attribute tables and then our elements on a map. So our attribute tables are tables attached to features where they have a one-to-one relationship between the records and features on a map. So if I can click on or select or query, give me all zip codes where the median household income is greater than $100,000. Remember we looked at those? There was a few of them around here in Cary and then up in northern Rockaway County that have those. You can see them blue on the map, blue on the table. We have that one-to-one relationship, so we can manipulate the table. It'll show up on the map and vice versa. The one thing about these, and sometimes when we run into some issues, is that if you look at an attribute table, it contains something called an object ID, that column all the way on the left. Like, don't mess with that, don't change that, because that serves as the link between your attribute table and your features on a map. And then it also contains extra features all the way on the right that might have perimeter, length, all those other things. And those might be really weird units because they're calculated in the projection of your original data. And what are the different projections we have? Latitude, longitude, state plane, all those other things. And remember, we talked about how far is a degree. Oh, wow, depending on all that trig stuff. And so we don't mess with those. What's that? It depends.
69 point something.
Yeah, about 69 point something miles. Standalone tables. They download those. It doesn't contain an object ID. It may contain spatial data. The one thing that we try to do with a standalone table is that let's look for somewhere in there that implies or indicates spatiality, that implies spatial relationships. Could be a county. It could be a Latin long. It could be an address. It could be anything, but somewhere that we can put it onto a map. And that's what we're going to do today with today's exercise. We might need to run additional operations like the summarize, tabular join, geocode, add XY. And so we have a tabular, we have a standalone table here where I click on Allegheny in Alamance County. You can see they're highlighted on the table. they're highlighted on the map. And this, I'm pretty sure this is taken right from the exercise right here, where that it's a little bit different when we look at things like infant mortality rates. Hey, this is a really cool table, but I want to link this to a map. Now, what is some of the problem? When we start linking these, what do we see here? I see the word Avery right here. I see the word Avery right here. What's the problems with this Avery and this Avery? Left justified, what else? Well, capital letters. So I guess I'm gonna have to create a new column and go type in capital A, capital B, capital E, right? I have to do that? No, well, why not? I guess we'll make Philip go capitalize. We're gonna make Mary capitalize all of these. Other operations in Excel or in ArcGIS Pro to just capitalize them?
To ensure that attributes suggest that rendering.
Yes, and also we have a calculation called upper or lower. And I don't know if in Excel it's like U case or L case, it depends, but we have calculations, just like we do with mathematical calculations, because everyone makes lines for the mathematical calculations, this column plus this column plus this column. We do the same exact thing with string operations. So I can make it upper or lower. Hey, let me look for everything to the left of the comma. That'll give me my town or whatever, or to the right of the comma, that's the state or whatever.
The other,
So we can do the same thing.
the other thing, Dave,
Yeah.
especially when you're doing names like that, that's why Dr. Murray records don't change if it has an index number, because certain states or certain things will be spaced differently. For instance, and Alondra might have some experience with this, El Paso County in Texas, in some cases it's LEL spaced Paso, in some cases it's not. Well, that moves it in the alphabet, it doesn't link it to certain stuff, and it screws up all your things. So having those reference columns that are standardized without spellings and without justifications makes things a lot simpler when you're linking data and stuff.
And Solomon and I, we just ran into an issue recently where someone typed in like Anson and then Anson space enter.
Yeah.
Remember that?
Yeah.
I wasn't gonna point that out, so I'm glad you're the someone, but we learned we learned a lesson, and that Anson space is a lot different. Now, if someone put an X right there, you'd see Anson X, but you put a space right there, no one sees the space. And so remember, computers are stupid. Computers gonna say, well, this is Anson space. They're not the same. I'm not gonna match those up. So computers are stupid in terms of they're gonna do whatever you tell it to do. And so those are important. So I just want to make sure we kind of understand all these issues here. Age adjusted mortality rates for different types of lung, female breast, prostate, colon, rectum, all types of cancers by county. Powerful data set. This is in PDF. I would love to map this, export this thing to Excel. Let's start cleaning it up because you got weird columns up at the top and all that other good stuff. But this is, you've got like a master's thesis sitting right here, ready to go with the different types of cancers, ready to go. What does this age adjusted mean again? Yes. So we adjusted, we normalized, basically we weighted. Remember that weighting? Remember that, weighted averages? We weight according to what? The 2000 US standard population. So we have a basically age specific rate, and then we have a weighted rate, because we do all this weighted all the time. What's the biggest example of weighted averages? GPA, exactly. Is that A in the 4-credit class going to count as the C in the 1-credit class? No, not better. I hope not. Never better. So we weight those. That's perfect examples of weighting. So even though old people have higher death rates, the 80 plus have higher death rates, there's a lot lower percentage of them according to the 2000 US standard population. So the power and effectiveness of GIS, we can sort, query, summarize statistics. Those of you who taken geostats will probably kind of rehash this right here, where that we have these different columns. And in ArcGIS Pro and even other applications such as Excel, when in doubt, right mouse click and something else will pop up. Okay, right mouse click over on the table of contents, right mouse click on a column name. What do we got? Delete, fields. Now these days, people grow brains and start like deleting fields here when you don't want to delete fields, okay? Also things we can calculate new fields. I remember someone recently in our North Carolina counties, like they added it from a service and then deleted one of the counties. And so we went through and it's like only 99 counties. Thankfully, Andy went back and added it again. And so even with these services, we can change editability and all those other things that take time that I typically don't have. But I can right mouse click and do statistics. What does that summarize do? Remember what that summarize does? What does summarize do? When we use summarize in geostats. It counts the number of times something appears. Because what we did, we got a big list of everyone who died of cancer. That's probably 20,000 people. We ran a summary on the zip code. And I think the first thing we had to do was convert that zip code to a actual text instead of number. Because where I grew up, I was 07865, my zip code. I think Dr. McGinn's zip code probably started with a 0 back in the day.
08527.
Yep. And so what does Excel want to do with that leading 0? I don't like this 0. My kids call them ghost zeros in math, but it's not. It really represents something. So you got to keep that 0. So we can convert those zeros to a text. So it's 5 digits long, okay? So we could create these at 5 digits long. And so we've got this zip code right here. And so we can summarize on the zip code, count the number of times, 07865, 27707, all these other zip codes appear. But we can also run statistics on these so that we can look at this nice, pretty graph. And what's this graph called? Histogram. Looks at a distribution. And typically, this is our nice normal distribution. This is the median age by county. So you can see over here, we've got Onslow County, where Camp Lejeune's located, which has a really low median age, a lot more young people versus old people right here. Most data that we work with, I like this. This is good. Normal distribution. Why? Because I can do standard deviations and all that other good stuff without adjusting it and all that other stuff. But like we talked about with like football or baseball, most of your teams are going to win between 7 and 10. Now with this whole 17-game season, it gets a little bit average is 8.5 or whatever. You're not going to have a lot of 15, 16, 17 wins. You're not going to have a lot of 0, 1, 2 wins. Most of them between 7 and 10 right there, where the frequency is going to be high. So we have value versus frequency using a histogram. And ArcGIS Pro, what's it have? It gives us the mean, the median, the standard deviation, and then we can just export. And these days, you hit a little screenshot, crop this thing out, change the, make nice pretty names right here. Instead of count, we put the word frequency, need_age, we change it to median age, and then we pop that right into an Excel or PowerPoint or wherever we want. So when we have GIS in tabular format, this is what it looks like. In Excel, we call them records, we call them fields or attributes, and where they intersect, they're called cells. But this is some of the data we have here. This is from Greensboro. This is the Greensboro Crime Mapper, 5300 block of West Market Street. Here it is, 4/21/2022. And pretty neat stuff that we can look at. If we know this address, we can find this. Now, when we manage data tables in ArcGIS Pro, we can calculate columns, easily calculate columns. Some of the things we were doing with Solomon, where it gave us we want to convert everything from degrees, minutes, seconds to decimal degrees, meaning 27.327 degrees north latitude, negative, 87.475 degrees longitude, because everything was given to us in degrees, and then minutes and seconds, which are portions of degrees and portions of seconds. You got to go through and like divide by 60 and then divide by 3600 and add all these things up. I don't want to do that. I don't want to degrees, decimal degrees. That's my big thing. I don't want to do conversions. I don't want to do math. I'll do math when I have to. So when we look at these, we can calculate natural increase, net migration. So if I know these estimates right here, what are the changes? What are the births? What are the deaths? What is the natural increase? The natural increase is just the number of births minus the number of deaths. And then we have net migration, 17,600 that come in. And so we talk about some of these population dynamics. You notice right here, and these are for counties. Alamance County had a natural increase of 1,943, but 10 times more with net migration. Now, this could be domestic migration, people from moving up there to down here, or people moving internationally. But most of the migration that you see in the United States, and I'm sure Dr. McGinn can attest, isn't from people coming from other countries here, even though you read about the news, you think that's the case, but it's people moving from other places to here. So we do have places where people are leaving, Allegheny, Anson County where people are leaving. Yeah, Anson County where people are leaving, even though it's got net migration. We got net migration from Ashe County. Well, what's happening in these counties? A lot more people are dying than being born. Why? And what do you think the age of the people there are? They're older people, so they're not being replaced. You can see they're not even being replaced. In some cases, they're not even being replaced by migration. But these are all the result of calculation of our birth and death data that we can go through and increase. And so we can look for something like percent growth, 100 times C2 minus B2 over B2. Basically, new minus old divided by old, right? New minus old divided by old times 100. Everyone who knows me, I don't like working with percentages like 0.72 or 0.02. I just want a nice percentage like 72% or 2% or whatever. That makes a little bit more sense to me. So now I can look at percent growth right here. I can look at the percent growth, 12%, 3%, 3%, negative 11%. That means population went down based on the old population. So can I have population growth more than 100%? Of course you can. Now, things like percent Hispanic by county, can you have more than 100%? No. Okay, so be aware when you do these calculations, at the end of the day, I can just drop and drag and calculate these percentages, but who at the end of the day really runs the calculation? You all do. But this dumb computer is going to do whatever you type in. And remember, if I don't put a little parentheses here, it's going to not put this, it doesn't care about your Aunt Sally and your order of operations and all that other good stuff there. So it's going to do whatever you tell it to.
So order of operations doesn't work.
Yes, order of operations is essential. So if I got rid of these parentheses, it would do 100 times C2 minus, well, what's B2 divided by B2? 1. So you're going to get a big nasty number right here. And you know what some people do? They just drag it down. Oh, I see 2 million% increase. Cool. That's one of the answers. All right. Makes sense. 2 million% increase. Okay. So, and a lot of times, everyone in this class will go back and say, oh, that number doesn't make sense. Oh, I forgot to put in my, I did a miscalculation or I switched these or whatever. Okay. What I like to do, I like to tell people I like to go through and hand calculate them first, the first column and then do it. But I just assume I'm the smartest person in the world and go and do it. And then when it comes back later, we notice that it isn't always going to be the case. So these non-spatial data come from lots of different places. Censi, I think they change it now to like data.census.gov, has got just tons and tons of data out there. You can go and type in everything, and these have links there. Department for Public Safety. Right now, you can go to this site right here, type in prison entrance by county for the last year, and it'll have the number of prison entrance by county that can be normalized by population. So we can start to combine data from two tables. So do we have a FIPS code? Do we have a county name? Do we have a Latin law? These are really great data sources. You can get so lost in the weeds with some of these things here. Me, I like kind of downloading my raw data, but these days, those services, remember yesterday we clicked, let me look at my content sitting in the cloud, but we can click on something called Living Atlas, which is like Esri data that you all have access to because we have access to Esri data. So I can type in median household income and it'll have data sitting there that I can right mouse click and just say export. But I don't want to look at it for the entire United States. I just want to look at it for my county. So I can extract from sites like this at the zip code or block group or block level. Zip codes really aren't too popular in census because they're something different. And so we can download data like this. We can make nice maps of colon, rectum, cancer deaths by deaths rate, lower CI, upper CI. What's this CI stuff stand for? What's that? Confidence interval. Confidence interval. On the right track. So when we create data, we create these attributes, and these are the things you need to think about. Hey, when I go out there and I'm collecting information about my telephone pole, what type of information am I going to need to collect? What is it going to be? Text? Is it going to be number? Do I need decimals? All these other things, because back in the day, my first computer had 8 gig of drive. Like 8 gig, yeah. 1995, I bought my first computer. It was like $600 or something. It was a big tower, but these days I lose like 8 gig, flash drives in my dryer. It's just. But back then, space was at a premium. So the amount of space to gobble up or take up stored decimal points is a lot different than numbers and text. So when we look at a parcel right here, this is my parcel here, and it has an owner, assessed value, bedrooms, deed, date, and acres. Number of bedrooms, what are the possible values? You can't have 2.75 bedrooms, so those are stored as integers. Where that acres can be stored as what we call floats or doubles. The difference between a float and a double is that just the amount of space that's taken up. But a float and a double are the same thing. We have things called longs and shorts. Short is the integers. Okay, short goes up to 32,000 something, like 2 to the 16th power, where that long goes up really, really long. We have dates that store things like 9/25/2019, and then we have text to store my name. So a lot of times if we're storing zip codes, even though it's a number, we really want to store it as a text because we want to keep these leading zeros, where that Excel wants to get rid of those things. So a lot of times when you import data from Excel, clicking that black plus sign, you are going to say, hey, it's missing my zeros. And we can go and add a 0 to the beginning of those things using something called concatenation. It's literally like adding strings together. It's kind of funny. You can add 2 strings together, like Tim plus Mulrooney equals Tim Mulrooney. Yep.
But I don't know what's going on.
Float and a double, float have decimal points, and then doubles have decimal points, but you can store like negative 72,000,000.527396. Where that floats, they start to crap out once you get to so many significant digits. And then we have things like blobs, binary large objects. We can store like metadata objects and files, images, pictures. So these are all things going on in the background, because when you go out and create your survey tomorrow, hey, I'm going to go collect a survey of a mountain bike trail. I'm going to go collect a survey of just some significant points around my home, which I'm hoping, you'll just go through and do. What do you want to collect? And remember what I did yesterday, that little survey that I collected? What did I say? That survey that I collected yesterday that compared my phone GPS with the other one, I took a picture, I had a location, it collected the data at the same time, and then I had a little drop down that says, hey, which GPS unit are you using? Are you using your phone or are you using the geo? It's called the geode. But which phone? And I used a little drop down there, so I didn't have to go and type anything in, because when you type stuff in, what happens? You screw it up. So you give less chances to screw up. We can also calculate new columns. Remember, if you store something as a long or a short, and then you want to calculate percentages that have decimals, it's not going to magically create those. So those are some things we need to be aware of. But we can calculate new columns. We can go to the fields, and I can add a short, long, float, double, date, text, blob, GUID, graphic user ID, or something like that, or raster. I don't think I've ever used any of these 3 things right here. And even dates I kind of keep there, because dates are interesting because we can sort those by date and time, where that other things get a little harder to do. But it tells us, hey, it's going to be a number. This is the number of decimal points places. Can we align it? Do I want to pad it with zeros? Do I want to show thousand separators, i.e. commas? So we can do those. And so I can go and calculate something called sex ratio. Sex ratio is the number of males for every 100 females. I think that's it. And I can create a little column here, because in our census data, I have number of males, number of females. I can make a nice, pretty map out of it. This is a layout. So this is a little bit different than a map there, where that I can insert a layout into things here. Now this has These maps in blue have much higher percentage of men than women. Where that these areas in yellow have much higher percentage of women than men. Why does this area right here have so many men? Dr. McGinn could probably answer better than the military. What about the places in like Northwest, like logging or forestry or?
Yeah, I'm there, I would say that, yes.
No.
What I've learned, and that might be Ashe County and Mitchell County, apparently there's a ton of retired, like CIA and live off the grid folks. that live off-
Oh, wow. I'm sure they don't have women living with them anymore. so.
Yeah, what's interesting on that one is that Cumberland County is an overwhelming brag. And I think that's because a lot of those folks live in Hope County and they're spread out more than they are in like Jacksonville, Church, and all that.
So, but we do see spatial patterns with these. Is this Green County or
That
something?
is Green County, you're talking down there, aren't you?
Yes.
Yes.
I don't know what's going on there. Farming?
Farming, Ranger.
Okay.
I think that's all that. And then, interesting is the upper northeast areas that are really light are predominantly African American counties, and if you look at in life expectancy, African American longer than that, so that would probably
Okay.
lend itself to some of those,
All right, so some of the things we're gonna do today after the break are, we're gonna join tabular data. I already kind of highlighted the Guilford County parcel search, where we have lots of different information about owners, assessed value, sales, tax. And in theory, no one should be getting their hands on all of these different tables at the same time. So we need something, what we call a key. And typically, a key in Guilford County is gonna be PIN. Property identification number, personal identification number. So your parking tickets with your bill, with your, car, your little card here, they're all going to be attached to you using your 820 number. So, the lady that you yell at the registrar, she's not going to go and like add more money to, give you a parking ticket or erase your parking tickets or whatever, or register you for classes or any of those other things, because those systems don't speak to each other, but they're all going to be associated using a unique 820 number. And so through the Guilford County, with all these things are going to be linked to using a PIN right here. So you can see these folks, attach these, and then we can look at, plat drawings and all these other things here. And so what we need is just something that implies spatiality. And basically what the exercise we're going to do today is we're going to have some standalone tables. I think I linked. And then I basically put up some data here. Why is it? But this is some data I've put up here, like domestic violence by county. This is a student, this is just some of the raw data for domestic violence rates, the number of calls, number of clients, white, black, African American, Asian, Hispanic. These are some, just some raw data sitting out there. These are deaths for 2014. This is a map of I'm sorry, I'm looking at but this is a map of every single death for everyone between the ages 15 and 25 for the year 2014. We can see males, females, race, death date, and then if we go far enough to the right, we can see what these people died of. And we had a student, she was a bus driver, and she wanted to look at all, and then all the way over to the right, what do we have? We have a zip code right here. We can run a summarize on the zip code to figure out what zip code, so that we can map those, because we looked at the zip code map yesterday. We mapped income, we mapped race, or we mapped whatever we want to by that. So these are the tables. These are just some examples of tables that I've been accumulating over the years. I think some of this stuff Dr. McGinn and I have done in the past. Okay, these are all the mail-in ballots of libertarian voters.
Yep.
And so, and I think we talked a little bit about this in data science class, where we can go to the State Board of Elections and it's got a big list of every single registered voter in the state. That's like 7 million of them, because Excel doesn't like 7 million. So we bring those into R, and you can probably bring these into ArcGIS Pro, but this is every single voter, libertarian voter. It's got an address. Look at these. these things. Can you map these people right here? Yeah. And then got the voter zip code, if we want to map these by zip codes. Now, stuff Dr. McGinn and I did was at the zip code level because we were associating these voting patterns with COVID rates. And the best scale we had was the zip code. But we've got probably thousands of libertarian voters sitting right here that can be mapped, and we can map them by zip code, county. And I think over here, we've got a race for them, Think about, you can do probably a whole PhD dissertation on this, The only limitations that we have are your imagination. So but we got tons of tables right here, income, health data, COVID rates, COVID and diabetes and everything else. So I after our break here, we're gonna go make a map of one of these things, because these are some standalone tables that we've got. The one thing that we need is that this is a standalone table right here. This is an attribute table. I know it's an attribute table because it's got the little object IDs attached to it. And so what we do essentially is we run something called a tabular join. We just say, hey, we're going to add this table to the end of this table that's mappable. And after a while, we're going to just have July 2011, July 2012, July 2013. At the end of my attribute table, that can be mapped. Now, remember, if I typed in Alamance with a space, and that's Alamance, you're going to have a whole bunch of null sitting there. What's null mean? It means nothing. I couldn't find anything. So we need to be careful about that. And so now I've got my attribute table. You can see that it's highlighted on the map. It's highlighted here. I don't see any nulls right here, and it's kind of run nicely and neatly. So now I can look at total population counts that were extracted from the North Carolina State Demographer. State Demographer, they don't know much about GIS. I gave a presentation one time, and he wanted to connect with some of the things we were doing, because he doesn't speak GIS. He knows enough of it, but we were doing some neat things with him. Now, what makes a key a key? A key has got to be unique. So I can't have like Burke County 3 times, because I don't know which Burke County you're talking about, but in North Carolina, there's one Burke County. Across the United States, there might be multiple Burke counties where we need to refer to a FIPS code for that particular county. And so it needs to occur the same exact way, where that Florida doesn't equal this guy. I know I'm dating myself here, so that's Florida, yes. I think he's not cool anymore, right?
Just from the single glass.
What's that?
Just from the single glass.
Okay,
Be big on the racings.
okay, good. Well, I'm still with it then. That's good. All right, good. All right, I'm not going to listen to my kids. All right. Well, we've got statistics here. What are some of the things? And when in doubt, a lot of times we kind of think about maybe the project that we're doing, the project that we're doing in this class. A lot of geostats. A lot of people want to go to, I want to do interpolation. I want to do two-tail t-test. When you write any paper, first thing we want to do is just some basic, these are what we call descriptive statistics. Hey, I got total number of voters in North Carolina broken down by county. This is the number of Republican, Democrat, Independent, Libertarian. That's a good place to start with all these. A lot of times people make beelines for, I want to do this robust statistics. Hey, let's extract some descriptive statistics using histograms. ArcGIS Pro gives us these things right here. We can do summaries. I already talked about some of the summary tables. Days of the week. For those crime data, it gives us the day of the week that it occurred on. Hey, we can see what day of the week was most frequent. See, Thursday or Wednesday was the most frequent day of the week for crime. Why is that? I'll tell you. Remember back in the day, in the 90s, my friend, he had a older brother, and he'd get paid on Wednesday, and he'd come into the city, and he'd spend like hundreds of dollars on us to go out, because he got paid on Wednesday. I don't know if Wednesday is still payday or whatever. I don't know. But this is some of the crime that we extracted, some of the crime data. I'm not sure about Wednesday. SIDSTEP. This is a powerful Now, this is a powerful one because one of our students were impacted by SIDS, but we extracted all 728 potential SIDS deaths, and we can look at the race and match these up with some of the data that we have. We can summarize and join those, so now we can look at a map of SIDS deaths by zip code. Tell really powerful stories from these data. And then last couple of things we'll look at here are, Climate Prediction Center. This data comes out every single day. I've got a lat, I've got a long, I've got a temperature. We can map these really easy. And then this is mapped using this is mapped using these coordinates are what we call geographic coordinate system, or using the World Geodetic Survey. These are addresses. Are these latitudes and longitudes right here? We got X and Y. Well, look at this big number, 202,70625. What does latitude and longitude go up to? Highest possible numbers. What's the North Pole in latitude? What's the South Pole in latitude? What's that? How many degrees is this? I'm really trying to make a right angle. 90. Yeah, 90. Okay. Yep. And how many degrees are in a circle? 360. So we go from 0 to 180, 0 to negative 180. 180 plus 180 equals 360.
Intro class fail.
Oh. Who took his intro class? Okay. So latitude goes from negative 90 to positive 90. Longitude goes from negative 180 to positive 180. So are these latitudes and longitudes? These are in feet. This is state plane. When we basically place North Carolina onto a flat surface, stick a 0 point down in Alabama, and just measure in feet, measure distances using your good old distance formula. So that North Carolina state plane. Yep, that's your northern and your eastern. So I can change this here. Now, this is all the stuff going on in the background that we don't care about, but to me, when I have this and I get a map like this, I know it's right. It's not sitting in the Atlantic Ocean. It's not sitting in the Pacific Ocean. These are all lined up where they should be. And this is just crime data. Right? So I have a couple things on geocoding, but how about we take like 10-minute break? We'll come back at 10:20. We'll just open up the exercise and do these and be done and go over tomorrow. That sounds good. All right, so let's make sure we got the day 2 stuff open, and then we'll. And this is what day 2 looks like here.
I'm gonna ask this thing,
I'm trying to figure that out.
That's not fair. I would actually bring my percent.
Get out.
And then there's still.
Yeah. That's what I'm thinking on this, like, when I'm reading, the option, that's.
Yeah.
Instead of a partition, you gotta reboot, go to that partition. You already want a partition.
No, but I just think.
Yeah, I don't think you can give them
Technology like that.
The way they do it, they tell you before you go out and buy it, and I didn't in the library, I think you on the floor, it's just that, communication is a big involved.
But they'll set up a partition.
Yeah, but I got some.
I'm wondering. That's what we're gonna have math. Is it possible for them to use computers and?
I'm not gonna say no on much.
No.
I'm still.
And then these, obviously.
Yeah, it's all have,
Have it on
Or
the
just-
desktops, yeah, so.
all the desktops are like that, throw on them, so it's just sign into it, yeah. We're not saying that. Great.
You know, the library gave me a computer, sitting before, yeah, and then they have a, I saw my neighbor go to download it, and have it, so I couldn't download the program.
You can access Eagle apps through it, but that's super slow. And then what would happen, because at least in the old days, and it probably happens in here, it's gonna wipe it. So if you, a lot of times, if you don't save it on a flash drive or hard drive, and it wipes it, it becomes a whole big issue.
Yeah, that VPN, you're connected to a computer, but it's, the computer fits in over the school ahead. So you gotta like download the zip file on that VPN and then open it up, and I would just suggest doing it here or getting it on there.
I'll move on to that. Maybe. Maybe these aspects.
Yes. Points. It's not calling me enough. So. So, okay. Just put it in. It's the day. That's actually. Right. Stick it. No, section though. Like, somebody reckons on the chat.
Teach the assessment. It could go once or twice. Some do it. It's very nice.
Yeah, we get the. Yes. There we go for that. Yes.
When's the next voting?
Probably not mid-June, other than. But then that's not. So. Their conferences. Probably that, man. Some classes that I did too fast. Per day. I got my third, I stayed in the line.
So did you go to high school with any of the Johnson?
I went with all the Johnsons.
Okay.
I mean, not all, of them. Rob,
He was 91.
yeah, Rob was the oldest.
Yeah. He was good at soccer.
He played like junior national team. He was probably better at soccer.
He came back, like, played soccer for a few years, and represented the rest of the senior year, and plays, I don't think he went to NCAA, but he's like third and.
Yeah, even, Tyrone was the next one. He was, I think, he was a senior when I was a freshman. Then I graduated with Jermaine. And then Derek's, who was a good wrestler,
Yeah.
but. Right before, I don't know, 10 years ago. I bet you it was because it was my 23. The parents owned like towing company, garage and all that stuff. Everybody knew them around town. And they got in the car. in the lake, like they did the creek, I don't know what happened. But anyway, and after that, there was Jermaine, because Jermaine was. Yeah. And then I got like those weird messages from their. They shredded it. And then the other brothers were trying to. Yeah, nobody sent my brother. Yeah, but I found it with that, yes. Thank you. So,
Now you got, what do you got there? Liberty or something? Is that about the other school down there?
yeah, and now so the big issues now, because they're closing one of them,
There goes the-
Memorial,
Oh,
because of the population, all the city Jewish population moving in. Like that's about my mom's house, that's about, or my whole neighbor is basically that. And they go to Orthodox schools. So they're
in Lakewood? Or in Jackson?
all over the place.
They have a civic, they have a school like that in.
Jackson, they're trying to build a temple. Yeah, so that's one of the big things, and there's a big argument because two of the girls I graduated with are like Shem Keller. And this was when I was up there, this was a month ago, and they wanted to, the logical thing is close Memorial, because it's old, and move all the students to Liberty. But Liberty is in the heart, Memorial is more where there's still Jackson, but it's Liberty is close to Lake, which is where the St. Jude population is. So it's a big fight going back and forth of, you know, what to do with that. Because they're also closing Getz, which is there's two middle schools, to high school, but the population, they're closing that. But what they're saying is the other side is you get more money if they sell Liberty to the city population. If it's right in the middle of town, they can convert it to one of their schools. So I don't know what's gonna happen. My brother still follows all of them. He just bitches about it. I'm like, yeah, we can't work with them. I'm like, I don't care because I'm there. So, but yes.
Yeah, that used to be one of the units was for, super, probably a couple thousand kids.
Yeah, I graduated with like 2,700.
What's that, a kid?
Yeah. No, I didn't graduate. I still had 2,700. 600, 650. Something like that.
I'm way north, I still had 1,200, for kind of. I'm like, where's that? Oh,
It's all civic things, but
okay.
Yeah. So Lakewood, which is in Ocean County, is down right now, but Lakewood was, when I was growing up, was always split, but black population and his city Jewish population. It almost mirrored like Brooklyn. We had that. And now everybody in Mount Jackson, which is next to Lakewood, the city Jewish population was over there. So they buy a neighborhood and they put a temple and they walk everything outside. So my mom came around for a certain amount, like close to $1 million, and it's a normal like 2,000 square foot, 2,000 house, but they all want to move over there around the temple, so it's just fine with that, and so yeah, it's interesting how that, and now Lakewood has become more actually expensive, populations are all over, so pretty interesting how that changes.
Did your mom move to like that big retirement?
So- Yes and no, it's a part of Holiday City, that's.
Okay, someone was telling me about that recently, like Holiday City, New Jersey.
Yeah.
I've never heard of it.
So she actually lives in a Holiday City community, it's just about nowhere, but there's not like gates or anything, even that. But because that was a big controversy because she's renting from the guy that was her neighbor. But she was all pissed off the other day because she couldn't get her pool back because Dave's on the mortgage. And that's the only people that get the pool back. So then they don't really have a lease, it's like a gentleman's agreement, they're paying cash because he.
Yeah.
So then they have to draw up like a fake lease with their name on it, and then Dave was all worried that this little old lady in Holiday City was going to report to the IRS as renting, and yeah, it's legal, right? It's just, you know.
Like,
Clearly, Holiday City.
that's like, you know, I had a condo.
Yeah.
I had to go get a little,
Right.
he was, you know, basically.
Yeah. But her block is like nearly within every neighbor. There's a little guy that I swear he's like CIA, he walks his little dog around, and the guy's on the whole street. My mom said something, I was like, it's perfect for you. She's like, what are you talking about? I was like, you're the gossip queen on the street. She's like, I just like to know what's going on. I was like, it's like the old lady. But yeah, it's right off like 37, good seaside.
Okay.
It's just Jersey. So they're so angry. Bitter. Driving and everything.
Take an hour, hour.
Yeah. You're from Jersey, you're from New York.
I'm from Jersey. I'm originally from Rhode Island, I've been gone 30 years. So,
Yeah.
Jersey.
Sometimes I got 30 years too. State, Texas, I don't think.
Should I ask about now?
Oh, we had a class,
Oh, that's right, I was supposed to do that yesterday.
this independent study or directed research on
For
summer.
some business.
There's 1 minute here, I'll get added and stuff here. I'm ready to add some data.
What's your? No, I can go in the back door and stuff.
All right, cool. We are getting back started here, 10:20. I plan on being here till about 11, just so we can add some data, show you how to add tables. There's tons and tons of caveats that we've got here that, tons of rabbit holes that we can go down, but this is kind of my specialty where that turning tabular data, how do we make GIS data? How do we make high quality GIS data? We're going to look at a couple things here with some joins and then some add XY, and then maybe I'll do a quick little example of some crime data, and then we've got this. So first thing we're looking at our ArcGIS Pro project right here. And I'm using ArcGIS Pro. You can do geocoding, you can do joining and all those other things using ArcGIS Online. The techniques are a little different, and to be honest with you, I don't really do it that much because I do all my products here, publish them to the web, publish these final products to the web. It has feature services, web maps that I can insert into web apps and web experiences and all that other good stuff here. And so some of the terminology that we have right here, we've got a map. A map is literally like a map, you know what I mean? It has spatial, relationships here. Down at the bottom right here, it's got the latitude and longitude where my cursor is posted here. It's over here, it's got this little scale, 1:4561639. What is this thing called? The little thing with the little colon there. It's called scale. Right, scale. And so on this map, 1 inch is equal to 4,561,637 inches in real life. And I think we talked about scale a little bit, where that 1 to 63,360 means 1 inch equals 1 mile on the map. So when we print it out or render it on a map here, that's what it looks like. So you can see some maps in the back there are like 1 to a million, meaning 1 inch on the map equals 1 million inches in real life. So those maps in the back of the room, you can't see buildings, you can't see roads, because if you did, it would be a really crowded map and really detract from the goal of highlighting age mortality or age-adjusted suicide rates. But if I were to zoom in, I would definitely want parcels. I would definitely want rows like we looked at. And the one thing about web maps these days is that you click that little knob right there, you're zooming in and zooming out. So we have these scale dependencies where that some things are going to be appropriate, some scales, some things aren't, where that we have these strict web maps that we've created. To me, there's still power in creating high quality cartographic products that you're going to see in newspapers or journal articles and all these other things. The other thing that we can do is we can insert a layout. A layout is what it's going to look like on a piece of paper. So a layout is where I can go and add a scale bar and text and, legend and all those other things. And to be honest with you, ArcGIS Pro, it doesn't really have the best like legends to me, as does the old versions of GIS software called ArcMap. ArcMap, I really like making the maps on these. I've got a couple of hopefully cartographic projects coming up. I'm actually going to make those in ArcMap, because even though it's been about 5 or 6 years since I did these, but we can insert a new layout and then insert the scale bars, legends, all those other things. Now on the left here, we have what we call our table of contents. We've got major cities, we've got counties highlighted in this kind of black outline, and then we have the zip codes that we showed yesterday, but I don't have the pretty colors on those because I just want to use those as background, or maybe we have some primary, or maybe you're going to go find something later at the zip code scale to do that. So we've got these, and then down at the bottom, we have standalone table. I've got standalone table from County Growth, DPD Crime, and then Air Max 2021. And it's relatively easy to go and add these. I can just go to my map, my black plus sign, and I can go to browse, and then I can go and look for these on my computer. So if I download a CSV file, I can download these on a CSV file. I can go to Timothy Mulrooney and my downloads, and wherever I download it, it's going to give me anything that could be a potential table. So here's my travel and reimbursement authorization form. Now this stuff's garbage because this is, meaning it doesn't have anything related, anything related to it. But when I download these things, I can just look for the CSV files or whatever I'm looking for here that I can add in, and it'll know that it's a standalone table. It'll know it's an standalone table. And from there, I can export those to a database. Okay, me, I don't like working with the raw CSV files. I right mouse click, I export it right to the database. And we did those a lot in geostats and data science. So these are all sitting in my database as standalone tables. So if I were to right mouse click on County Growth, and I could do open right here, this is the standalone table right here of Alamance County, April 2010 estimate, July 2010 estimate. We can look at the percent change, the births, the deaths, the natural increase, the net migration. Does this kind of look familiar here? This is kind of what we already did here. I went through and calculated the percent change. This thing has an object ID because I exported it to my database. I exported it to my database because when we go and make maps, I'm going to go to view and we'll go to catalog pane here. But when I go and make maps right here, this is my project sitting right here. So I've got some maps sitting right here. I've got some databases. I've got my geography 4950 data here. This thing here with the little cylinder, this is my database. Okay? And what I did here is I went to view, catalog pane, and then clicked on databases. I could also click on folders right here, and you can see my in-class exercise and all that other good stuff here. And you can see my geography 4950. This is just all the data that I've created for this class. So I've got like census tracts and some of the things that we looked at yesterday. So you can see I've got some tables, I got some major cities attached to these that are sitting in this database right here, this GDB right here. Now, when I extract it, remember when I did this before? Remember when I did this before? What does that GDB look like? It looks like one of these things, right? It doesn't have the little cylinder right here, and I can click on this, and I can go and like delete these things. What do you think would happen if I deleted one of these things in this GDB? Really bad things would happen. Bad things would happen. And that's kind of some of the challenges if anyone remembers working with coverages. Coverages were like 6 or 7 files. Shape files were 6 or 7 files. So I've got this here. It gave me an object ID just because I exported to the database. So, hey, we're going to be part of this database as well. Now, the one thing I want to do is I want to map the percent population change for this for this table. This is a cool table that I went and downloaded from the North Carolina State Demographer. Okay, it's got 2010, 2020, it has some percent change. It's got births, deaths, natural increase. We can do lots of things. We can like normalize natural increase by, population, lots of things here. And we're going to create a map of this data as it's sitting here in tabular format. And we're going to do something called a tabular join. We have something called a spatial join. We'll worry about spatial joins in Geography 4010. We took geostats, like week number 1 was spatial joins. You all kind of hit the ground running with that stuff here. We're not going to worry too much about those. So what we're going to do here, let's forget, and if we really want to, we're going to uncheck the zip code stuff just because we're not dealing with it right now. We are not dealing with it. Like our voting data, all we did was work in zip code data because we were looking at associations between COVID data, which we had at the best scale, and then all of the voting data. I could have done voting data at the block group, tract, precinct level, but I don't have COVID data at that scale. So we kind of unfortunately have to defer to the worst scale that we have data. If I had better data, we'd work with better data. And same thing with like death data, that death outcome data. Does it give you the address of every single person who died? No, it only gives you the zip code of the person who died. So we're going to have to defer to one of those 763 zip codes instead of the 2,200 census tracts or the 6,000 block groups that exist within North Carolina. What we're going to do here is now we've got counties. When in doubt, right mouse click. What can I do? Symbology. I can symbolize these things here, but first I got to add that table to the end of my attribute table. Because remember we did that symbology yesterday and I just said, hey, zip codes, median household income, COVID rates, percent minority or whatever. Okay, percent minority or whatever. I've got tons of different options. Remember, we did the view metadata. We've done lots of things here. Now, what we're going to do here is we're going to go to joins and relates, and we're going to do add join. Our previous previously we did add spatial join, where I had a map of every single person who died of cancer. I got that from state demography or Bureau of Health Statistics a long time ago, and we just counted the number of people by county who died, which was pretty interesting. But we're going to run something called a add join. This is what we call a tabular join. So I'm going to click on a join. And all we're going to do is just match up the little columns. So my input table is going to be what? North Carolina counties. North Carolina counties is what we call the feature class right here that can be checked on, checked off, symbolized, or whatever. And it represents the outlines of all counties in North Carolina. If you zoomed in enough, you can see the little bird seeds that make them up and all that other good stuff. But they can be measured using perimeter and area. So basically, I want to color in the perimeter and area because I don't know where the population increase is going because I only have 100 records. Now the input field. What is the input field? What do you think the input field for in NC counties is to represent the name of the county? Probably name, right? Yeah, name. Let's try name. Now, what do I want to match it to? County growth 2020. And what's the field that I'm going to match it to? Probably county. So you notice the names of these are different, but it's got Alamance, it's got Avery, it's got Ash, it's got all those things there. Do any of them need to be capitalized or anything like that? No. So, okay, and we could do a little bit of code, and maybe if we got a little bit of time, I'll show you how we can kind of convert those because it's one way in Excel, it's another way in Python or Arcade or whatever we're going to do there. But we can just make it uppercase so that we, or graduate students or undergraduate students, don't have to go and retype these. And I've seen people go and like type these in from scratch. And you let them do it once, and then you say, there's probably a better way to do it, because then you remember typing in all 100 counties, probably a quarter of which were mistyped or didn't work. All right, so we've got a name, a county, and I'm just going to click on this little thing here that says validate and join, just for the heck of it. And what does it say here? It says, okay, the input table has 100 and the join table has 102 records. Okay, well, that makes sense. Where are these 102 coming from? Just for the heck of it, Let me open up this table here. Let me go down to the bottom. It's got a couple of extra things here because it says like state and then it's got source because all I did was import this from the state demographer and it brought in a couple of extra rows that said state and source. And basically there's not a county called state or source. So it's just like, okay, you've got 102 records. So probably previously I should have just gotten rid of those, but I'm kind of trying to thinking of it now. So, okay. All right, and now when I'm ready here, let me click OK. I was waiting for like some bells and whistles to pop up, but nothing really happened. Let me open up the counties. Let me open up this count. Now, this is the attribute that's going to be attached. So if I highlight a couple of these counties here, look it, they're highlighted here. Now I've got a fix. Okay, got a fix. That's the 820 number for each of these counties. I've got something called POP 2010. What do you think POP 2010 represents? Population 2010. I've got race. I've got ethnicity. And these days, we've got a lot of this data sitting in Esri services. So I can go to like Living Atlas, click on population, it'll add this, and then I can just right mouse click and export these. All right, I'm excited here. I got multi-race. So this is all the original stuff. Now I go all the way to the right. Now, what do I have here? I've got a county. April 2010 estimate, July 2020 estimate, numeric, percent, births, death. Does this ring a bell? Do these attributes ring a bell? Where are these? They're sitting in the other table, matched up using this. This word is called a key. So we always need a key to match these up. And just for the heck of it, let me just go down here, make sure that I don't have any nulls whatsoever. No nulls whatsoever. So no one typed in Alamance space or anything like that. Now I can make a map out of this. Previously, I downloaded this from the state demographer, brought it into ArcGIS Pro, and now we're getting ready to map these things here. Because it's cool, you know, I like this. This is a pretty neat map here, but I would love to look at the spatial relationships. So now this table is sitting at the end of my NC counties attribute table. I don't think we did this in GeoStats, did we? Oh, yeah, we did. Yeah, we did with the deaths. Yep, we did this with the deaths. So it's sitting here, ready to go. So now I'll go to my map, clear. Now I can go to my map here of NC counties, right mouse click, symbology. Get rid of this catalog here, move these folks here. What do I want to map? Now I'm mapping polygon data. Okay, this is what we call a choropleth map. So me, I like using graduated colors. This bivariate stuff, I start getting confused really, really quickly. What does the word bivariate mean, you think? Two variables. Two variables. And so it starts to look with some oranges and blues, and I still haven't, I don't want to say figured it out yet, but. So graduated colors. What do I want to map? Instead of POP 2010, hey, let's go down to these things we just brought in. Percent change. You see spatial patterns with these? Here's the percent change using natural breaks. Everyone knows me. I love the quantile here so that each color appears the same number of times. So this is a 5-class quantile. So this color appears 20, 20, 20, 20, 20. If we look at the histogram, let's see what that histogram looks like. Histogram of percent population change by county. Look at this. A nice, pretty histogram. Now, look at the spatial patterns of these. Do you notice spatial patterns? Where are people leaving? Northeast right there. And we can change these. If we go to, instead of quantile, I change intervals. I could change these to intervals saying, hey, let me make anything less than 0. And instead of making it less than 0, put population decrease. But all these counties right here in yellow are counties where people have left between 2010 and 2020. Now, how are they leaving? One of two is people are either moving or they're dying. and they're dying at higher rates than people being born and staying there. But spatial patterns related to these. To me, I find this, really, really neat. I'm kind of interested as to this county next to Charlotte is really high, and then this county and this county really, really low. These are really low. So we've got a lot of neat things that we can look at here, but this data was just sitting here from the state demographer, 20 minutes ago. We downloaded it and brought it in. Another thing that we can do is let's look at something like net migration. All right, this is the net migration right here. Now, I'm mapping this column here. These are raw numbers. What are some things that we should probably do with net migration? Normalize it. Okay, normalize it. Why would we want to normalize it? I bet Wake County is going to have more people migration. Why? Because there's more people in Wake County. So I can normalize it to look at percentages. So I'll normalize it by this. So where do we have more net migration? A lot of the same places where we're having percent population increase. And I bet you, if we were to net migration, numeric. And if I were to normalize it by none, look what we have here. This is just the numeric population increase. These are some counties over where I am. Probably a lot of people here. There are people leaving. And then we can also extract out births, deaths, natural increase. Look at the natural increase happening here. We can normalize these by population. Now we can start to see some of these counties over here, Okay, a lot of people leaving, but people having people high right in these counties here. So the people who are staying are having counties, but a lot of people are leaving. Like just this data right here, you've probably got like a master's project on this, just sitting right here. A neat little master's project going through and analyzing some of these things and looking at the co-relationships between these. But, I really can't stress enough that this data was just sitting at a table, state demographer made from a lot of different data sources, 20 minutes ago. And now we're getting ideas about net migration. These are all the things that hopefully you all talk about in Dr. McGinn's class. Sounds like a lot of people forget them in Dr. McGinn's class. With, push factors, pull factors, percent increase, rate of natural increase, natural increase, net migration. And like we said before, this net migration is usually people leaving other places to come here or leave. And this net migration happens within the state. So people are leaving certain places in North Carolina for other places or even out of state. Really, really neat data sitting here. Now, the other thing we've got, and I think I have links to these, let's look at some more stuff we've got here. We're going to look at Air Max GIS 2021-04-17. So this data, this was the maximum air temperature. Now, those of you taking data science and geostats know this data set really well, right? Right? So this is the maximum air temperature sitting for this date, 24/17/2021. I took this from the NOAA Climate Prediction Center. So every day they have a big 5,670 record table as a text file of every air station in like North America, latitude, longitude. This one is the max temperature, but they got a separate file for min temperature, snowfall, and rainfall or something like that. Really rich data set. And in data science, basically what they all did was they read these in using a model and they like created maps of these on each day. Remember that? It was pretty cool. Now, the first in geostats class, we just read it in, and then we made like an interpolated map of North Carolina using these 100 or 150 stations. Now, we're going to make a map of all of the United States using this, and then we can extract these out for North Carolina if we want to. So we've got latitude and longitude. If I got latitude and longitude, can you make a map out of it? You bet. I bet you could type in latitude and longitude in Google Earth or anything else and look at these here as well. So we're going to do this now. Okay, we've got elevation, all these other things. So now we've got a table here. Once again, we can right mouse click. This is a little bit, now we got geocode. We're going to look at that there in a little bit here, but we got create points from table. And a lot of times, if you look at some of my tutorials, these might be slightly different because these context menus change from version 3.1 to 3.2. I think I'm working with 3.3, and then version 3.4 is available right now. So it kind of looks and feels the same, but you know, you might see some minor differences here. But I'm going to XY table to point. So we're going to go to XY table to point. My input table is going to be this. My output table is going to feature class. So I'm going to create a feature class that's point, lines, or polygons. And obviously in this case, it's going to be points because we have lats and longs, but we can create things like routes and polygons. We can do tons of different things here. Now, what's my X field? Is it going to be my longitude or my latitude? Longitude. My Y is obviously going to be my latitude because I'm going to run it again and switch it, and you're going to see what happens. And you say, oh, that doesn't look right. And those are, you know, to me, when you make mistakes, that's the best way to learn stuff. Kind of like our thing when we typed in ants in space. Okay, yeah, now I know better. Like, hey, spaces matter. Spaces are things. Sad thing is, or the difficult thing is, we can't see those. Now, the coordinate system. What is the coordinate system? These get into big, deep questions here. Do I want to use the current map? I can click this little globe thing, and then I can go look for lots of different things here. These days, Web Mercator is the way that we display data on the data on web maps because you can zoom in and zoom out. Because yesterday we talked a little bit about North Carolina State Plain. What does North Carolina State Plain do? Minimizes distortion for what? State of North Carolina. And so does it care about what Idaho looks like or Canada or Africa? No, it doesn't. It just minimizes distortion. So if you zoomed over to North Carolina or Idaho, it would be tilted. If you zoomed over to Africa, it'd be really big. Doesn't care. Why? Because all it cares about minimizing distortion for North Carolina. So these days with our web maps that are on phones, tablets, screens, we've got a projection where we can minimize distortion for stuff we zoom in on, stuff we zoom out on, stuff for the entire United States. So this Web Mercator is like 10, 15 years old, this projection and the standards for those. Now, with all that being said, we don't need Web Mercator. Okay, but I want to explain that because you're going to start seeing Web Mercator pop up more and more these days, and they have units attached to those. Now, what we have here, this is what we call WGS84. So the default projection system's right there. Look at all that stuff right there. It's like WGS, it's got a datum and it's got a spheroid. This is World Geodetic Survey from 1984, and it's based on the size and shape of the Earth collected from 1984, because they have one from 1927, they have one from 1866, when like the first survey of the Earth was taken. And those, the degrees of like latitude and longitude are slightly off because the size and the shape of the Earth was not different. It was different because they measured it differently. So 1 degree isn't 69.02732 miles. It's like 69.0274 miles. And so that all changed just slightly off. It's like 200 meters off. And so when I work with the military, we were bringing things in from one datum to the other and we misdeclared it, you'd see it's like off like 200 meters. You just got to change the datum and say, no, we're displaying it using the other one, and it all lines up nicely and neatly because the size and the shape of the Earth, it's always changing. Why? Because our technology is getting better to measure these. So if you use the old technology with the old standard, it's gonna kind of get tweaked here. So all this weird stuff going in here, look at this 637.137.0. Does anyone know what that 637.8137 is? That is the radius of the Earth in meters. So 6,300, and that's about 4,000 miles. About 4,000 miles, right? What's the circumference of the Earth at the equator? How far is it around the Earth at the equator? About 24,000 miles. What's the calculation for the circumference of a circle using radius? 2 pi r. What's 2 times 4,000 times pi equal to? About 24,000. Oh, yeah. This stuff all kind of makes sense. Now, if we were to use a different projection system, this number would be slightly different because we've never really dug into the Earth. We've dug into the Earth about 8 miles, what, 15, 14, 15 kilometers. So using our techniques, so if we were to use a different 1984, about 1866, 1927, this number would be slightly off. This is what we call, this is what we call flattening ratio, that 298. Previous datums, it's like 297. Flattening ratio is how much different the equatorial circumference is versus the polar circumference. Like in a circular sphere, isn't the radius the same everywhere? Isn't it? Isn't the radius the same everywhere in a circle? It should be. And if you are out of a sphere and kind of rotate it in 3 dimensions, shouldn't it be the same everywhere? Should be. The Earth isn't. Exactly. Okay, excellent. Earth isn't a perfect sphere. It's kind of a semi-solid, so it's got that centripetal force, so it bulges a little bit at the equator versus the pole. So this number is the average radius. It's not the polar radius. It's not the equatorial radius. It's the average radius. So these numbers are going to be slightly different at the poles and the equator. It's something like 12-mile difference, which equates to about 1/298, 1/300 difference. Not really perceptible by your eye. So these are all kind of the input parameters. So this is like measure of a degree and all this stuff here. If you get into the geodesy, and I think Kareem, you probably know some of this stuff a lot more. You could probably explain this a lot better than me because Kareem comes to us from a surveying background, right? Do you have anything else to add, or have I? Oh, good. All right. I'm still pretending to. So we got this. We could, you can go into all day about just projections, because tomorrow I'll talk a little bit about projections, because all we're going to be doing tomorrow is going outside and collecting your real world location according to this. Now we can convert those easily to geographic coordinate system, 1866, North Carolina state plane. Once we have this, it's really easy to convert these, but we're going to tomorrow just go out, collect all this stuff using a little phone, using our GPS unit. We're going to connect using Bluetooth.
That's why if you switch the whole of that, between the X and the Y, it's gonna be.
Yep. Oh, I'm going to show the difference. I'm going to show what happens, because a lot of times, if anyone knows me, I just click next, 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 and then something's wrong. Now we're going to run this. Here we go. Here are all the stations here. Cool. I got some down in Puerto Rico. We recently went to Puerto Rico over here. We went to this little town, Arecibo, or it's a big town, Arecibo. But look at this here. This looks pretty cool. Now, just for the heck of it, let's right mouse click. I'm going to do create points from XY instead of lat, because I'm going to go lat and long. Uh-oh. There it is. Well, I just switched latitude and longitude. It's a bad move. Okay. And obviously I'd kind of figure out, hey, I did something wrong right there. So we'll go back, rerun this thing. So I run these, you have a bunch of points down in Antarctica. Obviously, I've switched these because what kind of latitudes in North Carolina, what kind of latitudes are we looking at? North Carolina. What's the right answer for latitude? 30 something, exactly, 30 something. Okay, one thing I use as a point of reference is New Orleans is right at 30 degrees north latitude, negative 90 degrees west longitude. So 30, 90, so we're like 32 to 36 and then in the negative 80s. So when I switch those, what is negative 80 latitude? South Pole. You know, so you notice all that stuff down towards the South Pole and Antarctica. So I'm going to right mouse click, add XY, longitude, latitude. Here we go. And now I've got my temperatures right here. All right, so I can click on this little point right here over in Durham or over here in Morrisville. I click on it. You can see it's got this latitude, it's got this longitude. It's called RDU. What do you think RDU represents? Raleigh-Durham Airport. And on April the 17th, 2021, the maximum temperature was 69 degrees. Yeah. April 2021. Yeah. Now, I should have a link to the current stuff that we can do and bring straight in. Now, what we did in our data science classes, like we brought these in for a week and like we processed these. Now, I want to go over to the zoo. Zoo over here. Does anyone go to the zoo a lot? I try to go every year. Yeah. Go to the zoo. A lot of walking, huh? A lot of walking. They used to do a 5K there and like, you know, you run up the hill and down because it's in the middle of the Uwharrie Mountains. But it's pretty cool. Tried to take my kids there just because I wanted to sleep on the way home. All right. But so here, do we have any idea what the temperature is here? Right in the middle here? How can you guess? What's that? A lot colder. How can I guess it quantitatively or empirically? Temperature around it. What's that called? Interpolation. Okay, so interpolation. So this is what we did in geostats class, where we extracted out the data from North Carolina and we created interpolated surfaces of, hey, this is what it might be here. This is what it is here. This is what it is here. This is what it is here. And we're not going to do that here. All we're going to do for now is we're going to extract out a data set from North Carolina so that I don't want to look at the other 5,670. I don't want to create an interpolated. I don't care what it is in Puerto Rico. Now, the one thing that we did in class where that I kind of got wrong was, should I keep the temperature for these stations right here, just to the north of North Carolina? Are they going to impact? Yeah, why? Exactly, because it's environmental. You know, things like, you know, median household income, all those other, you know, phenomena, especially social phenomena, are collected at administrative levels, but environmental data like air quality, water temperature, all those, they don't care about these administrative boundaries. So one of the things we can do is, and what we did in my class, in our class, was I just gave you the North Carolina stuff. I was probably wrong because North Carolina, when it comes to environmental data, isn't necessarily an island. So can I calculate or create all the points that are outside within 50 miles of this? You bet I can. We did this all the time. So we can do select by location. I want to select the input features. And if I were really smart, when I export these out or create these, I give these nice pretty names instead of what ArcGIS Pro gives me. Now, instead of intersect, within a distance of, well, what's left? NC counties. And I'm going to type in 50. Now, do I want to type in decimal degrees? No. Okay. 50 degrees is going to be really big. 50 what? Statute miles. What's an international nautical mile? How far is that? How far is a mile? 5,280 feet. How far is an international nautical mile? Isn't it 6,000 feet? I think it's 2,000 yards, exactly. So when you hear like nautical miles or going at 5 knots or whatever, it's like 1.15 miles. I don't know why they do that. So I'm gonna click apply.
Imperial system.
Yeah. So what do we have here? Now I've got this brand new feature class. I've got 201 points. Okay, and this is some of the things that we like doing here, because I don't want to work with this entire data set. So the last thing we're going to do today, because I want to get us out here soon, is we can right mouse click. We go to data, and now we can export these features or export the table. In GeoStats, what do? We just copy table stuff, plop it into Excel, plop it into SPSS, and run our two-tailed t-tests or correlations or whatever we want to do, even though we could do some nice little geostatistics here or statistical methods here, but I could just pop those out here. But what I could do is just data, export features, and I'm going to export, use, extract selected records at 201. These are my input features. This is my data, this is my database. I assume this is the database that it was originally in. I'm just going to call them max temp study area. Okay, I'll probably forget this later, but that's okay. And then I'm going to click OK. Because one of the things about maps is that we've got all this data, and I think we get overwhelmed with all this data. I don't need all these points. You know what I want? I just want these points. And that's what some of the things like Amazon are really, really, really good at. When you go shopping at Amazon, it's like, this is what you want. Here's a couple other things you want. Pay now. I've always seen shopping pages that have like red flashing stuff and everything, and I get overwhelmed. The same thing about maps, because it's hard to look for like 12 different features at the same time on a single map. We get overwhelmed, and I think that's where people get, I don't want to say lost, but inexperienced map users kind of get lost here. Now I can go and create my interpolated surfaces sitting right here using data within 50 miles. So now I know what the temperature is here. The temperature here is going to be based on, all right, probably some of these points here where that North Carolina isn't necessarily an island. And we can create those interpolated surfaces. But we just created something using what? Data that we downloaded from Climate Prediction Center. And this is what we did in data science, where I went and downloaded like 10 of these, and then students wrote a little script to create one map, another map, another map, another map, another map, another map, without ever having to point and click. They probably did it once, and then they wrote a script that just automated this. That wasn't fun. That was like week number 1. Remember that? You're like, that was probably like one of the hardest exercises, to be honest with you. It was tedious, but then once you did it the first time, I'm just going to repeat it. I'm just going to change the little name of it, and we can write Python scripts that do that, because especially if there's naming conventions with Air Max 04, 22, 20, and 21, what do you think that the name of the next day is going to be? Air Max 04, 2023, 2021. O Max 04, 2024, 2021. And so we can, concatenate strings and all that other stuff. I've got this ready to go. If we want, we can go to View, Catalog pane, sitting right here. I can do we stored it in COVID map for some reason or another, probably because it was sitting there, but we got pickpocket crimes, I guess. Air max temperature. We've got this data sitting right here, created at 5/17/2024 at 11:05 a.m. That's right about now. We're ready to go here. All right, so we won't do anything else. I'm just going to give you the homework, and then we can kind of go from there. So I'm about done. I'm done. Let's leave it with that. So exercise, all we're going to do is you're going to make a map of anything that you want. Okay, make a map of anything you want. I've linked it to this Google Drive for ADHD statistics, deaths, crimes. If you want to look up some of the crimes, you can take the geocoding module that we have. So take the geocoding. If we have things with counties, we've got a domestic violence by county, raw data. We had a student who was really interested, a social work student interested in studying domestic violence. This is the domestic violence data sitting right there. If you want to map the number of calls, and sometimes raw numbers are good, like deaths or hospitalizations, especially with fire and emergency response, to look at true capacity. You know, we don't care about normalized rates. We want to know where to allocate resources in the events of flooding. So Wilmington might need more beds or more resources because they got more people. And so we need to budget that appropriately, because I know I harp on normalization a lot. But you can map anything here. Libertarian mail-in, suspension, this student wanted to map suspension rates by county. Here's a county here, 82 out of every 100 students get suspended at some point in time in the year. Zip code health data. So we've got some zip code health data sitting right here that you can map. I've got the zip codes that I loaded into an MX, or not MX, the APRX file sitting there. So you can just download this, join this using the little zip code there. There we go. All right, everyone feel good about that? I'm going to be here for the rest of the day here. I'll be here till about 4 o'clock. So go grab me in my office if you want. And the main thing I want us to do is make a high quality map. So insert a layout, make a little scale bar and legend, and got other data sources out there utilizing. So I'll see you all later. I'll see you all later here. Anyone can connect with me later about getting the getting access and all that. I think everyone here, maybe everyone joining us online, is having trouble with usernames and passwords. Just send me an invite. We'll connect. Make sure you're able to log in. I also have a couple of TAs that are available. I got a TA that's available. He's doing some work in my other office there. So we'll see you all later.